Hello folks. So in this video I'm going to cover various methods to do bivariate analysis when one of the variable is numeric and another one is categorical in nature. So we generally utilize z-test, t-test, ANOVA or analysis of variance methods from a statistical point of view, and if we want to use visualizations, then we could either use line chart or bar chart to do or to perform bivariate analysis for numerical and categorical variables combination, in fact. So folks, this is Nitin, who is on the mission to democratize the artificial intelligence, big data, Hadoop, cloud computing and blockchain to the entire world. And with this aim, I'm creating the associated content and publishing it on the periodic basis in order to make it available for the entire community who wants to learn these modern technologies. You can subscribe to my channel or press the bell icon to keep on getting the latest updates regarding the hottest technologies of 21st century. You can also follow me on Twitter at the link given above. In fact, I'm on Facebook as well, so you can go through our Facebook page as well. I have also added subtitles in languages like Hindi, English, French for your convenience, so you can enable them as per your needs. Okay. So let's start with the line graph, and let me open the Jupyter notebook where I have embedded the diagram which I have created. Okay, so let me open the. So here's the Jupyter notebook. I have embedded this diagram in the notebook itself. Okay, so in this particular video, I'm going to cover this part: categorical and numerical variables. So where one variable is categorical in nature and another variable is in numerical form. Okay, so in that case we either perform t-test, z-test, ANOVA, or so these are statistical methods and these are visualization techniques: two y-axis plot, bar chart and line charts. Okay, so I will be covering all these in this video as well as upcoming videos. Okay, so the question is, what is a line graph? First of all, so well, a line graph is a graph with points connected by lines to show how something changes in value. And when we say how something changes in value, that means uh, as the time goes by or as something else changes. So it displays information as a series of data points called markers connected by a straight line segments. Okay. Now in bivariate analysis, through line chart or line plot, we try to find out the average of numerical variables for each category of categorical variable in order to find out the relationship among them. Okay, so let's go through the line chart which I have created, or the line plot we have created. So I have created the mean values of, in fact, I have calculated the mean values of sepal length, sepal width, petal width for each species. Okay, so if I scroll down, okay, let me go here. Okay, so you can see here I have created the mean. So this is my iris data frame wherein I have entire iris data, and I'm grouping this data frame on the basis of a species, and then I'm creating a mean out of it. Okay, and this is for resetting the index. This particular method is for resetting the index. So you can see that species are Setosa, versicolor, virginica, and you can just neglect this ID column. Okay, so it doesn't have any role to play here. We can in fact remove this column from here. But you can see that these four columns: sepal length, sepal width, petal length, petal width. So it has created the mean values for each and every category. Categories are Setosa, versicolor, and virginica. So these are our categorical variables. This is our categorical variables, and these are our numerical variables. So we have created or calculated the mean values for each of these columns for the species combination. All right, so next I have created a line plot by using a plt dot plot, and then I utilize this df mean data frame. Okay, and from there I just picked up species column, and so only sepal length I have picked up. So the y-axis is sepal length, okay, and x-axis is the species mentioned here. Okay, so you can see that the line plot is created here. Okay, and from this line plot you could visualize that Virginica has the highest average sepal length among all the three categories. Okay, so this is the sepal length column, and Virginica has the highest average sepal length among all the three categories. Okay, so this is the way we create the line plot to visualize the values for categorical numerical combinations. Okay, so let's move on to z-test and t-test, which are essentially same with a subtle difference. They both basically assess whether the average or the mean of two groups are statistically different from each other. That is, this kind of analysis is appropriate for comparing the averages of numerical variables for two categories of categorical variable. So we calculate the z statistics by using one formula. Here I can show you. So you can see this formula here, this particular formula, and this formula is for z statistics, and below is for t statistics. Okay, so z is equals to x1 bar minus x2 bar divided by a square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So here x1 bar and x2 bar are averages. Okay, and s1 in fact sigma 1 square and sigma 2 squares are variances. Okay, and n1 and n2 are nothing but observation count. So z is a standard normal distribution here. So what we can figure out from this particular formula is that if the value of z is small, then the difference between two averages is more significant. I repeat, if the value of z or the z statistics is small, then the difference between two averages is more significant. Now talking about the difference between z-test, okay, and t-test, the only difference between z-test and t-test is that we use t-test in case the number of observations, that is n1 and n2, okay, is less than 30. Okay, less than 30 means 30 is observations or records, you can say. So the equation in case of t-test is here, given here, right? So it's x1 bar minus x2 bar divided by square root of s square, okay, and in brackets 1 upon n1 plus 1 upon n2, where s square is equals to, so x, this s square is calculated here, right, with this, by this formula. Okay, so n1 minus in fact you can see that xi minus x bar x square plus some, and this is a summation from I equals to 1 to n1. Okay, so this way we can and this particular similarly for so what I can say is the s square is equals to summation of x1 minus uh, x1 square uh, plus sigma of, or the summation of jth minus x bar square. Okay, don't go into the formula details because I know you will be lost in the mathematical calculations, but just for your reference purpose, okay, how this t statistics is calculated. But if you need to involve yourself into mathematical formula, then you can dive deeper into it. Okay, there is a whole lot of theory associated with these two statistics. So moving on, this n1 plus n2 minus 2 is nothing but degree of freedom. So for our sake, let's calculate the z statistics for sepal length of categories setosa and versicolor. Okay, so here I have opened my Jupyter notebook. So what I'm saying is, so we will be calculating the z test or statistics for sepal length of categories setosa and versicolor. Okay, and one thing to note here is that number of observations in the categories in both the categories, that is setosa and versicolor, in both of the categories the number of observations are 50, okay, which is greater than 30. Therefore we are calculating z test statistics here. Otherwise we could have calculated the t test had it been lesser than 30 or equal to 30, the number of observations. So we would be manually calculating the z test in this case. Okay, and one thing I would like to tell you here is that first of all, what I'm trying to do here is, first I'm creating the mean values. Okay, so this is the way I can create the mean of species or the categories, which are setosa, versicolor, and virginica. So I'm creating or calculating the mean values for these three categories for each individual column, which is sepal length, sepal width, petal length, petal width. Okay, so first we calculate the mean by using this formula, and then we calculate the variance. The difference is only with this for this method. Okay, so you can, so instead of mean method, you can just include var or variance method to calculate the variance. Okay, here, and as I'm highlighted, so here is, this is nothing but I have calculated the z value or the z statistics using this formula. So this is x1 minus x2, so x1 bar minus x2 bar, where x1 and x2 are mean values for those two different uh, categories, which is setosa and versicolor. So here you can see that for setosa the sepal length value is 5.006, and for virginica it is sorry, for versicolor it is 5.936. so that's why I have included here. So this is x1 bar minus x2 bar, so this is x2 and this is x1 bar. Okay, and then next is, so here we have divided by square root of variance square divided by observation, number of observation, plus variance 2 square divided by number of observation in that particular category. So you can think of it as, this is setosa, so x1 bar is for setosa, x2 bar is for versicolor, sigma 1 is square upon n1 is for setosa, and sigma 2 square divided by n2 is for versicolor. Okay, so the same thing I have done. So I have used numpy to basically do these mathematical operations. So here you can see that first I have included the square root for this thing, square root. Okay, so this is x1 bar minus x2 bar divided by square root, and then I have done the square of variance values. So variance here, if you see, so here if you see this code, in fact, so what I have done here is I first calculated the mean values for all the columns, which are sepal length, sepal width, petal width, for species setosa, versicolor, and virginica. So same thing which I have done here, I did here, and there is a reason I have performed these operations. I'm going to tell you. So then next I created the variance, and then I calculated the count, because these were the three things which are required for this calculation. mean, variance, and number of observations. So I calculated these values individually first. Okay, and if you see this code, I just dropped the ID column. So this particular code is familiar to you till here, right? And this dot drop ID x is equals to 1. This means that I'm dropping the ID column, and x is equals to 1 depicts the column. If it is 0, then rows, and if x is equals to 1, x is equals to 1, then it is column, it depicts column. So I'm dropping ID column, which because we don't require it, and then I'm prefixing the values with uh, individual identifiers. So for if it is mean, then it should be prefixed by mean. Here you can see that. If you see here, so this is prefixed by mean, so that means these are the mean values. Okay, and if it is prefixed by var, this means that these are the variance values, and if it is prefixed by count, then it means it is the count value. So you can see that there are 50 observations each for Setosa, versicolor, and virginica. The total number of observations are 150, but for each individual categories, uh, okay, it is 50 records are in Setosa, 50 in versicolor, and 50 virginica. So here I have calculated, and then after that, once I calculated these mean, variance, and count values individually, then after that I concatenated using this method, concat method, all the three values, and the axes I kept as columns. Okay, so you can see that all the values are calculated here. Okay, so that's where I'm utilizing these values for the calculation. Okay, so here uh, once again, x1 minus x1 bar minus x2 bar, these are the mean values. So x1 bar minus x2 bar, which are these two, and then after that, square root of variance square divided by n1. So variance is, so this is the variance value, which is 0.1242. Okay, and divided by number of observations, which is 50, and then for the second category, which is versicolor, it's 266,433. Okay, divided by 50. Okay, and then when we calculated the z statistics, it came out as minus 22.3707, and so on. Okay, next what we need to do is we need to calculate the s square. Okay, right. So if you see here, okay, uh, sorry, we don't need to calculate the s square in this case, because obviously we are calculating the z statistic and not t statistics. Okay, so here I'm just calculating the, sorry, my bad. So I actually accidentally stepped onto this particular calculation. This is not for, this doesn't belongs to z statistic. It is actually belongs to ANOVA, or analysis of variance, which I'm going to cover in next video. So let me so it is for analysis of variance, ANOVA. Okay, and then okay, so this calculation is for analysis of variance, which I'm going to cover in next video. So but for our sake, we just wanted to calculate the z statistics, which we calculated here. Okay, and the value came out as minus 22.3707. Okay, and if we look this value, okay, in the z table, okay, or the z statistics table, okay, the probability will come out as 0.0001. Okay, so let me do, so the p value or the probability came out as 0.00001. Okay, and this is very low. Okay, this is the probability is very low here. Okay, and I repeat once again, we actually look this z value in the z table to find out the probability. Okay, so I just directly try to see the value, this particular value minus 22.3707 in the z table to find out the p value, and the p value came out as 0.00001. And this probability value is very low. Okay, so that means it depicts that the difference between average sepal length, which is this, okay, and the for setosa, and that is the difference between average sepal length for setosa and for average sepal length for versicolor, which is this one, okay, is significant. Okay, so I repeat my statement once again. The low probability depicts that the difference between average sepal length of setosa and average sepal length of versicolor is significant. Okay, so folks, this is it for this video. To conclude, I explained the numerical and categorical type of bivariate analysis, also explained and plotted the line graph, as well as explained the z-test and t-test, and then later on computed the z-statistics. So folks, here is today's question. Do you feel more comfortable with graphical techniques of statistics or the mathematical form of it? Please post your comments in the comment section given below, because some of the best tips and feedbacks come from you only. And if you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. And in case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with us, guys. I will be covering next topic in the upcoming videos. So keep on watching. Thank you.